Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by TechStrong and TwinGate. My name is Cody J. Brown, and I'll be moderating today's session. We have an exciting presentation ahead of us, but just before we begin, I have a few housekeeping notes. First off, today's event is being recorded, so if you miss any or all of the discussion, it will be made available to rewatch. You'll receive an email after the webinar concludes with a link to access the on-demand. We want to hear from you, so please feel free to send in your questions at any time throughout the program by using the Q&A feature. We'll try to address as many questions as you can send in, so be sure to send them in early. I'd also like to direct your attention to the chat tab. Let us know your thoughts, say a quick hello, or tell us where you're tuning in from. And finally, at the end of today's webinar, we'll have a drawing for 4 $25 Amazon gift cards. So be sure to stick around to see if you're one of our 4 lucky winners. Let's go ahead and kick off our webinar. The topic today, challenges to securing CI/CD pipelines. And I'm joined today by Alex Marshall, co-founder and chief product officer at TwinGate Inc., and Eran Kampf, director of engineering at TwinGate Inc. It is my pleasure to turn the floor over to Alex to get us started. Thank you so much for being here with us today.
All right, thanks, and great to meet everybody. We're looking forward to your questions and hopefully a lively discussion. As you just heard, so I'm one of the co-founders of TwinGate, and our mission is to make adopting zero trust principles easy. So what we're going to do is hand it off to Eran to go through, sort of like the core of what we want to talk about today around CI/CD pipelines, and so we'll hand it over to him.
Yeah. Hi, so I'm Eran, Director of Engineering here at TwinGate, and today we want to talk about why CD and CI pipelines are difficult to secure, and what we can do to improve our security there. So before we start going over the different topics, you notice the Swiss cheese here. And that's basically to show that, we treat all the security, the different layers of software that we need to secure in order to secure the entire pipeline. And not all the layers will have holes in them, right? And when these holes align, we have a breach, right? So our job as engineers or as DevOps people is to continuously work throughout these different layers and improve, fix these holes, hoping we'll never get like the alignment, right? We want to minimize that chance. With that said, it's a process, right? You'll never have like a perfect slice. It's a process of continuous improvement. So the topics we're going to go over today. So the first one is the first difficulty in securing the pipeline is that CI/CDs require access to secrets and privileged resources. They're actually one of the the biggest consumer throughout the system of secrets and access, because it needs those secrets to deploy, to build the artifacts, all that stuff. It runs third-party code, so not all the code we run in our CI pipeline is made by us, right? So a lot of software has different third-party dependencies. You've probably heard about SolarWinds and Code Cove supply chain attacks, and we'll go into details on that soon. You need to support multiple environments, right? Linux build, Mac OS builds, so you need to run your CI and CD pipelines in all sorts of environments, and you need somehow to monitor the configurations and settings in all those environments. Developer resistance, we'll go into detail on that soon, but developers don't like to work hard, and security makes them work harder. So there's a way to handle that. And we'll touch that less today, but there's always compliance issues, specifically PCI, and all sorts of other regulations that affect the stuff that we're doing in our CI/CD pipeline. Okay, so let's start with developer resistance. It's the easiest one, right? So good developers are lazy. They don't like to do extra work, and we have to help them. And the best way to help developers is to add as much automations and tooling as possible, right? So We want to ensure code quality, use as much automated tools to check the code for first for bugs, but there are tools that specifically check for security-related bugs. For any language, there's a different set of tools, so we don't go into the specifics of that, but you probably know the tools for the language you're using. So it's very important to run all those SaaS tools, linters, every code styling, anything that you can as part of the pipeline to help developers comply. You don't want to count on developers to do it themselves or remember to do it themselves. You want to have tools that verify certain things. And the second thing is one of the most important things we said, CICD is one of the biggest consumers of secrets and secrets, actually, right? So, and we want to make sure those secrets are never in the code, right? So so you don't want the chance of someone by mistake committing an API key or some other secrets. And there are tools to monitor the code for that. And we'll go over where they should be soon in the next slide. And another aspect of that is you want to monitor your dependencies to avoid supply chain attacks, right? So you want to keep your dependencies up to date. You want to track security updates. There's a huge database called NVD that all the different tools access to. But whenever there's a new security vulnerability discovered, there's an entry on that database, and there are different tools that will alert you. So GitHub does this automatically if you activate Dependabot, the bot that updates dependencies. And if you're not on GitHub and you're using some other service to host your code, or maybe on-prem, you can use other services like Sneak.io that does this for you. But it's very important to monitor both which dependencies go in the code, and then monitor when they get updated or if there are new vulnerabilities discovered on those third-party dependencies. And same thing goes to not code dependencies, to image dependencies. So if you're using Docker, a lot of developers would, when they need something, they'll just Google for that image. They'll find some image on Docker Hub and they'll use it. And you really don't want that because you don't know who made that image and what he put in there. So you'd really, you really like to maintain monitor which images you use, and also monitor which images you start off from, right? So either have a list of these are the only base images we allow to use from, for example, I don't know, the Python base image, and not any custom like image, or have a process to audit and authorize these images. And the second thing you want to do when you publish these images, so basically when you use Docker, your build artifact is a container, you publish it to some repository, like if you use JFrog or Google repository or AWS repository, and you want to have tools that monitor the images there. And same as we do with the third-party dependencies, they find outdated OS packages and the security vulnerabilities on those images, right? And you want to keep them updated. For example, we're using Google Cloud, and we have the Google Cloud Security Scanner on top of our Docker repository, and we get reports whenever like a package is out of date and there's a security vulnerability to fix that. The next topic we want to talk about is secrets, right? So we already said that we never want to have secrets in source code, right? So where do we want them, right? So we want to use industry standard key management system that is made to store secrets. And basically what those systems generally do, and we have a couple of examples here, SOAPs and Vault, and we can talk about them. But basically, the idea behind them is that they store them encrypted and only inject them when they're actually needed, right? So not all the secrets are available all the time. Only the ones you need at a certain time point are available to you. And you have fine-grained access control. You can control which processes and which users can access which secrets. So for example, if you have a non-prod and a prod environment, non-prod is probably for developers to play with. You don't mind them, changing API keys, adding new stuff, but you don't want them to be able to add, change, or even view production-related keys, right? So it's very important to use SOAPs or Vault, and that's a whole. Secret management is a topic for a whole different, deserves a webinar on its own. Yeah. Okay. Third issue we want to talk about is protecting your CI/CD infrastructure, right? So we have our CI/CD running in different locations, right? So maybe some of you are using Jenkins on-premise, maybe we're using Circle CI, so we have our CI/CD running on a remote environment we don't control. Or you're using GitHub Actions, so same like Circle CI, it's in an environment you can't control, but you want to ensure as much as possible within those limitations, those different platforms, that everything is secure. So the first thing, so you want to protect your source control repository. Obviously, not everyone should have access to it. Not everyone should, be able to commit code. So probably that's part of your development process. To have like gateways of how code goes into the product, right? So for example, you use PRs and you define that every PR has to be reviewed by 2 different members. And you have like, once something is committed, it goes through all the automated tests that we discussed before. And there's like another gateway between dev and production. That's a good example, but something you really need to think about is, the development process and what are the stops and blocks and gateways to code getting into your repository. And code includes code and adding new dependencies, stuff like that. When it comes to the CI/CD infrastructure itself, where, like, for example, if you're setting up Jenkins locally, or even if you're using Circle CI or GitHub, you want to automate all the configurations related to that. So for example, Jenkins, obviously you want to use Terraform to automate setting up the Jenkins cluster and all the workers and all of that. But even if you're using Circle CI or GitHub Actions, you can use Terraform to automate the security settings. Who can access what? GitHub, in GitHub we're using security groups or teams to control who can access which builds. So you really want to have those configurations in code, because that way they're auditable. You can see who changed it. You have a tracking history, etc. Okay. And one of the things we learned, so basically this presentation is based on lessons we've learned doing this for a lot of time. So we've been doing it for a couple of years in Twingate, but personally I've been doing this for over 15 years now. And then one of the things we learned, and one of the best ways to avoid supply chain attack, like what happened with SolarWind and CodeCove, is just to block all outgoing traffic from your build machine, unless it's an authorized destination, right? So for example, you can access npm.org or PyPy to fetch and install dependencies, but you don't want some code calling some unknown host that you didn't audit before, right? And for those of you who don't know about the SolarWind and CodeCove attacks, basically what happened there is that developers had third-party dependency the SolarWind library or the code coverage library. It's a standard library that a lot of people use in their code to measure code coverage of unit tests. And basically what happened is that they ran unit tests and ran the library to post this, to analyze the code coverage. They ran it as part of their CI/CD pipeline. And there was code inserted in that library that would read all the environment variables of that machine and send it to some, unknown source, right? Probably China, right? So, and those environment variables contains those unencrypted secrets that we talked about earlier, right? So you do want to block all outgoing traffic to avoid such attacks, right? You don't want traffic from your CI/CD going anywhere that you didn't plan ahead for it to go, which is usually just, authorized the Docker Hub, NPM org, and stuff like that. Okay. Now let's talk about accessing. So if you remember from the first slide, there's two parts to secrets, right? You need to access secrets, and they need to be encrypted, and decrypted only when needed. And you need to access secure resources in order to actually deploy, right? So maybe you have a Kubernetes cluster that you want to deploy to, or maybe just virtual environment, virtual machines that you want to deploy code to. Do stuff on, right? End of the day, we need to deliver something that runs on a server. So, so there are three approaches to secure those assets. Basically, you want your CI/CD pipeline to access a remote resource, and there are three ways to do it. Usually that resource is on a separate network, or hopefully, but there are three ways to do it. And let's go over them in detail. Right? So the first one and the simplest one is just to have public endpoints. So your CI/CD environment can access directly the resource that it needs to deploy on or do something on, and do whatever it needs to. So, and for example, on Google and on AWS too, that's the default setting, right? If you set up a new Kubernetes cluster, the master node has a public IP. And then from your CI, you can access that master, run, deploy, and whatever you need to do on Kubernetes. Of course, that public IP is protected by a certificate, right? You need a Google certificate or an AWS service account certificate in order to be able to access it. But still, it's a public endpoint, so you have to protect it. If you're doing SOC 2, which probably most of you are, it's still a line that you have this public endpoint, and you have to explain it away. Maybe it's a low risk, but it's still written there. So it's something you have to take into account. So it sounds simple. It's simpler for developers, right? Because they can access. They don't need to set up extra infrastructure, just a service account. But the complexities hide behind it, right? It's still a SOC 2 report issue. You still have to monitor them to guard that there's no security issue. So maybe there's a security issue in Kubernetes and you have to patch it right away, because otherwise, whenever you have something public and there's a security vulnerability, any kid with a port scanner can just scan the internet, find your server, and hack it. Right? You don't need the special hacking abilities. So having public endpoints like this just increases your attack surface, and it's something you want to avoid when possible, right? So the other option is to split the CI and CD parts into two different systems, right? Sometimes you have to do it. So we said, for example, if you have to do like PCI compliance, you have to do it. But the way this works is that you have a CI environment, the build runs there, all the automated tooling that we discussed, they run there, and then they publish an artifact to an artifact repository. This could be a binary, or maybe it's a Docker container that you publish to a repository, but the result of every CI process is some artifact like that. And basically on your environments where you need to deploy stuff. So usually like you have a production environment or maybe there's a bug here, a non-prod VPC.
Hey, Ron, actually, I think the slide isn't updating, actually. Sorry to interrupt.
Oops.
There we go. Yeah.
So there's a bug here in the graph. It's a prod VPC and non-prod VPC. Okay, so the slide didn't update, so I'll go over it again. Basically, you have a CI environment. There's a build script running there. The result of the build is some artifact, a Docker image, or whatever you're building. And then you'd have it gets published to a build artifact repository, and then you have a CD system running inside the same VPC of the environment you want to deploy to, and it listens to changes in the artifact repository. For example, it detects there's a new Docker image version published, and then it runs the CD process of taking that image and deploying it, or running whatever your CD workflow needs to, right? So some advantages to this is that it can be done even with a managed solution. It doesn't mean you have to install everything yourself. You'd need to, for example, if you want to do it with Circle CI or GitHub Actions, you'd need to pay them more money to allow running their agent on your infrastructure, right? It's quite expensive, but it's possible. Or you can use the managed service, the Circle CI GitHub Actions, only to do the build, and then something else that you install on-prem to be used as your CD system, for example, like Argo CD, or there's a bunch of them out there. But the bottom line is that it's a lot more infrastructure to maintain, right? So there's a CD system, whether it's GitHub or Circle CI agents or Argo CD or whatever else you're using. You have to provision it, you have to manage it, and you have to do it multiple times per the number of different environments that you have, right? So here we have prod VPC and non-prod VPC, but in real environments, this might be like 4 or 5 more. So even for Twingate, we have a dev, staging, production environments, and they're completely separate. So if we chose this way, we'd have to provision, monitor, and manage at least 3 different CD systems, right? But it does give you complete isolation to the environment. The CD system runs in the environment, and it can access whatever it can on that environment, and you can run whatever CD workflow you need to run. It doesn't support least privileged access, meaning you're running inside the VPC, so you have access to everything. So the CD process, whatever runs in it, has access to whatever there is on that VPC, unless you explicitly prevent it, like configure firewall rules or whatnot. And then the third way is to use a zero trust solution like Twingate. This is a Twingate presentation, but there are other solutions as well. And basically what it does is that you have a proxy on your CI CD environment that allows you to access the different environments that you need on the cloud, whether it's prod or non-prod, and it controls that access. So it supports least privileged access, because being a zero trust solution, it means you can configure for each consumer of resources exactly which resources it can access, right? So the production build can't, so the dev build won't be able to access production asset, even if it tried, even if there's a bug in the CI, right? So it's a bit more secure than the previous solution, and less infrastructure to manage, right? So you have to have this headless client as part of your build, and you have to have some way for it to connect to that VPC. But usually those, in all the solutions we know, those are relatively lightweight things. So for example, connector is usually just a Docker you have to run inside the environment. Headless client is just some Linux binary that you have to run and give it a key. So it's way more lightweight than managing multiple whole CD systems for every environment. Yeah, so we covered the basic like layers of security and a basic checklist of things you'd want to look at for each layer. We do have some tips specific to Circle CI later on, but with that, I want to give it to Alex to go deeper into how we access secure resources.
Yeah. Okay, great. Thanks. So yeah, what we'll do is we'll sort of like just zoom out a little bit and sort of talk about sort of like zero trust in general and like how that relates to this. So this whole concept, so like this last part of what Iran's been talking about in terms of protecting access to privileged resources is a topic very near and dear to our hearts. So if you go to the next slide, just a little bit of context. Let's see once that updates there. So the reality is that, you know, I don't remember, it's been a little while and I don't remember the last time I worked somewhere where everything was actually sort of within four walls of the business. But you know, that was an era that existed for a long time. And there's actually been a lot of sort of like follow through on that model sort of surviving, even though that's not how we work today. So it used to be that, of course, everything was in the four walls of a company. People were there, access points were there, the actual infrastructure was there, everything was really in one place. And so what you need to do is really protect that, those four walls like you would physical security. So there's like very close analogs. But now if you look sort of like what we sort of term like this new model, like what's really happening in the world, as Iran was sort of pointing out earlier on in the first part of the presentation, is that everything is really completely distributed and it's only, going more so in that direction. So people live everywhere, people work from everywhere, people use different devices, the applications they need to access are different. And that I think applies like very much sort of the CI/CD world, where you now have this like separation between these different tools. And then the privileged resources that Iran was talking about earlier, they can be in, yes, they are in a hosted location most likely, but they could be in multiple locations. And so it just makes like this whole process of trying to secure access that much more difficult. And so if I go to the next slide, the traditional model, which is a technique and technology I know that absolutely everybody is like very familiar with, which is VPN. And is that really like the VPN like sort of grew up in this era where there were those four walls that people needed to protect. And the example we have here to sort of more conceptual, and I'll bring this back to how this applies back to CI/CD pipelines in a second, is that in general, you have, when you're using VPN for access to resources, you have that VPN sitting as a sort of like public gateway as the entry point. And so for the end user use case, right, that's really what's on the slide here. It's like fairly like straightforward to understand. But really for what we see in even CI/CD pipelines is that for the hosted versions of these pipelines, people are still tending to use sort of like open VPN or other VPN standards. And the issue there is that you've got that sort of public attack surface that Iran was talking about earlier, I think in his first example, where you still have something that's public and something that needs to be secured. And then you also have this issue of sort of like distributing not only sort of like the access credentials for the client in your automated pipeline, but then you need some method to ensure that specific parts of your pipeline or maybe the whole pipeline can only access like certain internal resources. And that's not something that this technology is really very well like suited for. So if you go to the next slide, what we've got is, sorry, around the next slide, please. There we go. So on the next slide, yeah, what we've got is a slightly different model, which is a little bit what Iran was talking about earlier, which is that it's more of a distributed model, right? So you've got the proxy that he was talking about, which we call the client that sits on the user's device. And then you've got something like the connector, which again, this is our terminology, but these are for, fairly well-known sort of standards around zero trust. The connector is another proxy that sits inside the environment. And so now what you can do is you can provide like very granular access from either, human user or a service account or some other automated process, and give it access only to exactly what you want to provide it access to. And then because all of that's sort of managed centrally, at any point in time, if you need to, you can, revoke, service keys or revoke credentials as needed, right? So you don't need to worry about, or I guess you spend less time focusing on ensuring that the right keys are in the right place, because you can actually split them up fairly granularly between your different pipelines in different environments and have central control over what those service accounts have access to. So I know these couple slides here, we're talking more about sort of like the end user access. So if we go to the last slide, my section here, the same thing applies to, oops, the next, there we go. Next one. The same thing applies to, yeah, to service account model. And so this is something that we support sort of in our environment, and again is like, is something that's available in some other like zero trust platforms. And the idea is that you have a single sort of like unified platform where you're actually determining who has access to what, both human users and service accounts. And so this lets you basically set up these least privilege access rules, which again, Aaron was talking about earlier, is sort of best practice to then provide access to specific addresses as part of your internal infrastructure, as opposed to entire networks. And in our particular case, again, fairly standard sort of like service account model, super flexible, right? So it's a Linux-based like client, Windows client as well, if that applies to your environment. But the idea is that you deploy these service accounts centrally to determine what resources they should have access to, and assign them to particular pipelines, so that you can very closely manage, what those pipelines have access to. So there's a link in here. If you're welcome to go check it out. It's just an example of Circle CI workflow that we've set up using our service account. But as you can see, like in general, like the deployment model is like very simple. Like you just need to install the binary as Ryan was talking about earlier, right? So there's one line to do that. Second line is just to set it up, which establishes its privileges with an assigned like service key. And of course that can be managed lots of different ways, but should be done through like secrets management. And then you simply start the process and you're up and running. And what that does is that if you insert that as part of your pipeline, that particular job only at that particular point in time has access to the resources that you've assigned to it, right? So you've got this like very, very granular method of assigning access to particular resources. So that's sort of like how sort of like the zero trust sort of model like fits into this. And so what I'll do is I'll hand it back to Aaron to go through some tips and tricks for Circle CI specifically.
All right. Thank you, Alex. So Circle CI challenges. So we'll start with the things we weren't able to completely solve with Circle CI. So the problem with Circle CI is that you can run a build in SSH mode, and basically it keeps the build machine running, so you can access, you can SSH to it and debug something if you need to. The problem is there's no way to access control who can access that machine, right? So anyone in the company could basically SSH into that machine and on that machine you'll probably have access to those secrets that are required for deployment, the service account key, for example. So if, for example, you're running a build that builds production and deploys to production, and you keep that machine running, anyone who can SSH to it, which is everyone in your engineering team, would basically have access to do whatever they want in production, right? So how do we avoid doing that? Circle CI doesn't really provide a way, but there's a way to mitigate that, and we'll go over it in the next slide. Basically, you can control who can run the build, right? So you just don't let anyone run builds to production. And if they do, and they do allow SSH to that build, then it's their responsibility, right? And we discuss how to do that in the next slide. Another thing you can't do on GitHub, on Circle CI, but on GitHub Action and probably all the other hosted solutions that I know of, unless I missed something, is because you don't control the infrastructure, you're running on their machines, you can't really limit the outbound traffic, right? Unless you run their agent on the agent, the Circle CI agent or GitHub Actions agent on your infrastructure, but then it's going to cost a lot more, right? So those are the limitations that we have with working with Circle CI and GitHub Actions at the moment. How can we solve them? Circle CI access control. So it's kind of a hack because it's not really documented, but basically Circle CI has the concept of context. So you can define different contexts, and basically context is a bundle that says, here are a bunch of secrets in the form of environment variables, and here are the people, in our case, since we're integrating with GitHub in Circle CI, here are the GitHub teams that are allowed to access those secrets, that context, basically. And when you write your pipeline YAML, you can attach a context to each step, right? And if a build is ran by someone, if a build requires a context and someone runs it and is not part of the teams that are defined by that context, Circle CI will not run it, right? So basically what we did, and you can see in the screenshot a simplified version of it, we basically defined two contexts, production, non-production, with some secrets in them, specifically the service account key. And we just don't let anyone run the production one, right? So there's still the risk that we discussed in the previous slide that someone in the admins can run a production build and run it in SSH mode so that machine stays alive and anyone can SSH it. But since there are not a lot of admins who are allowed to run production build, it's their responsibility to make sure they don't do it, right? Or if they do it, it's for a very limited time because something bad happened and they really have to debug. There's no other way to debug the problem. Yeah. So with that, back to Alex.
Great. Yeah. So I think that about wraps things up. So what we want to do is just talk a little about like who we are to give you a little more context. While we're doing that, like think about what questions you want to ask. I think Mathieu, if I'm pronouncing that correctly, has a bunch of questions. We'll get to that in a second. So don't let him dominate all the questions and please ask. So quick background, quick context on like who we are. I mean our whole team at TwinGate, I think as we've hinted at a bunch, like we're very focused on and very passionate about solving like the zero trust problem. A lot of what our where our sort of passion lies is basically finding like elegant solutions to complex problems. And what's motivating us overall, what our long-term vision is really be able to get us all to a future where we can basically work securely from everywhere. And so that includes everything from employees accessing things remotely to everything we're talking about today in terms of like actually securing infrastructure, right? And so I think we look at how the internet is set up today, where almost everything is sort of on the public internet somehow, and it seems safe until it's not, right? You just have to think about things like Heartbleed and other hacks like that, and just realize that the concerns are very real. So we come from a wide range of backgrounds, and we're just super passionate about this whole area. And then on the next slide, just to give you a sense of like some of the customers that work with our technology, all over the place, and I think it just demonstrates that this is sort of like a very generalized problem that every company faces. Everybody's sort of thinking about how can they secure every part of the infrastructure from employees down to services. So with that, let's see if we can go over to some questions. Let's see. I think there was an earlier question around. I don't know if your sort of like experiences on this. I've been doing this a long time. I think there's an earlier question from Mathieu around like, are there like general frameworks or anything that's like helpful when people are thinking about how they're approaching all this? What have you found to be helpful?
So there are multiple frameworks in every layer, right? So the way we discussed is there's the build phase, development. You want to automate and the tooling, and you want to control who can access. What's the process to commit code to your repository, and have some safeguards there so that people don't commit secrets, or do stuff that they shouldn't be doing. But I'm not aware of. I couldn't name like a specific, framework. I think the best approach in life in general, right, is to read all these different framework and pick the stuff that works for your team, because every team has the special needs and stuff like that.
Yeah. That makes sense. Yeah, I think there was So there are a couple more questions here. So another one was really around like how do we or how should anybody think about potentially like government or nation sponsored hacking groups and how that might relate to protecting infrastructure. It's a tough question, but curious on your thoughts.
Yeah, it goes back to what we discussed earlier about the SolarWind and the CodeCov attacks. So basically there are two ways, right? If you have a public attack surface, I couldn't say what state nation-sponsored CIA stuff, what they can hack, or which encryption keys they can or not. I don't think I think that's why you should basically avoid having or reduce your public attack surface. But it turns out those guys have smarter ways to get in. That's why we had the SolarWind and the CodeCov attacks. It's easier to go to open sources and commit malicious code there than to directly attack you. And I actually read a paper about it. I don't remember the name, about a few weeks ago, but there was a professor in some university here in the US, and they did the research. They purposely tried to implant malicious code in different public open source projects, specifically in the Linux networking stack. And they found out that on 80% of the times they were able to commit their code, pass coding review and all that stuff. So I think government entities that have a lot of resources, sure, they do have the capabilities to hack, brute force, hack certificate keys and stuff like that. But they have more resources to do stuff like this, right? And that's what happened in the CodeCov and the SolarWind attacks. And there are ways to protect from those kind of attacks, which is what we discussed. So, yeah, I hope that answers that question.
Yeah. Well, I think like the lesson is I think on this topic especially, I think I really like your Swiss cheese analogy, that at the end of the day, like what we've seen and heard and learned from customers and everything else that's going on in the world is that it's really about defensive depth and all these different layers. And the more you can do in like different sections, the more it adds up, and it adds up more to the sum of its parts. But I do think like one of the things that I think we're in particular super passionate about is like just taking things off of the public internet, because it just invites people to try to like probe and scan and just wait for some vulnerability to show up. So no easy answers. Okay, so I think there was one more question. There might be another one here coming, but so the question is also from Mathieu was, is it possible to host red, blue, purple teams in a CI/CD environment? And does that make sense versus having some kind of like dedicated black hat, white hat team?
So just to make sure I understand the reference. So there's a methodology of a red, blue, purple team where one team builds, the other team attacks, and the third team works on defending against attacks. I don't know. I've never been in a company that actually implemented this infrastructure. I would say that when we worked on our CI/CD pipeline and on Twingate in general, we do find it's helpful and also required by certain certification to have a third-party company that specializes in security to take a look at the code and the infrastructure. And we find that it's really helpful for someone coming from the outside, looking at the code, looking at the architecture, trying to break different things. We find it very valuable to find new things that we could fix and improve in our infrastructure. We're a small company, so we do that with an external company. If you're someone big, like, I don't know, SAP, probably you have those teams as internal teams, like with these colors that you mentioned.
Mm-hmm. Yeah, the different color teams. Yeah, great. Well, I think I'll just emphasize that it's always good to get an outside opinion, a group of people that are thinking differently, because you can often sort of end up in your own little echo chamber on things. But yeah, okay, great. I don't think there's any more questions, but yeah, hopefully everyone really enjoyed the discussion. I learned something, so that's good. But I hope everyone else did too. We'll appreciate it, and thank you. Hand it back over to you, Cody, I think, at the end here.
Outstanding. Thank you so much, Alex and Aaron. I'd also like to give a quick reminder to the audience that today's session was recorded. Following this webinar, you'll receive an email with a link to access the on-demand. You can also find the recording living on the DevOps website. Just visit devops.com/webinars, and it will be waiting for you. Now on to the 4 winners of our $25 gift card drawing. Our first winner is Eric H. Our second winner is Ophir K. Our third winner is Dimitri A. And our fourth and final winner is Natalia C. Congratulations to the 4 of you. Please keep an eye on your inbox to claim your gift card. And if you don't receive that email, just check your spam folder. Again, Aran and Alex, thank you so much for taking the time to put together this program. And I'd also like to thank you, our audience, for being here with us for the entirety of today's session. This concludes today's program. Have a great day, and we'll see you next time.
Thank you.
Thank you.